Right, this video we are going to be looking at differentiating some polynomials. Sorry, I'm just going to get myself a decent pen for this. So we're going to be looking at differentiating different polynomials. Now this is y equals 0, which would cause a few confusion on a lot of students. We just think about what happens with y equals 0. So y equals 0 is actually this line here, the x-axis. There's y equals 0. If I draw it on top of that in red, okay, that's the line y equals 0, and we can see the gradient of that is always 0. That y equals any number always gives us a gradient of 0. So therefore, the derivative of that is equal to 0. Let's go on to this one. Now, if we differentiate y equals 6x, and if you remember y equals mx plus c, then m is the gradient. So the derivative dy by dx is just equal to 6, just like in y equals mx plus c. Page down, let's have a look at the next one. Now we get into our rule, times by the power, take 1 off the power. So we times by the power first. So if we differentiate, we get equals 4 times 7. Take 1 off the power gives me 4 times 7x cubed. So 4 times 7 is 28. X cubed is our answer. Okay, let's differentiate this one. Well, this is just another y equals mx plus c. Type 1. If we write it in a different order, the m is the minus 2x, so the gradient of this is just minus 2. So dy by dx is just 2. On this one, let's do times by the power, take 1 off the power here. So dy by dx equals 2 times 2 times, take 1 off the power, gives me 1. Remember, numbers, adding or taking away, do not change the gradient, so that does not come into our gradient function. So we're just left with 4x. Have a look at this one. Times by the power, take 1 off the power. So times by the power, we get 4 times 4x. Take 1 off the power, I get 3. Numbers added or taken away don't affect gradient, so we don't put that in. So we get 16x cubed. Now before we can do this, we must multiply out the brackets. And don't forget that this is x plus 5 times x plus 5. X times x is x squared. X times 5 is 5x. 5 times x is 5x, and then 5 times 5 is 25. You always should get 4 terms, which you're going to combine to get you this. And now we're ready to differentiate. And we use our take 1 off the power, times by the power, take 1 off the power. So times by the power, we get 2. Take 1 off the power is 1. Now, if you just look at the 10x plus 25, just remember that's just like y equals mx plus c. So the m is the gradient, so only the 10 comes into the gradient function. So 2x to the 1, which is 2x plus 10, gives me my gradient function for this one. Now, before we do this, it's not very, for some students, it's not very easy to do this as it stands. So what we do is we turn this into negative power. So remember, this is the same as y equals 4 times x to the minus 3, which obviously is 4x to the minus 3. And then we can times by the power, take 1 off the power to get our rule. So times by the power to get our differentiation function, minus 3 times 4. And then we've got x. And we take 1 off the power, gives me minus 4. Minus 3 times 4 is minus 12. And we've got x to the minus 4. Now this is just the same as, we do x to the minus 4, it's the same as 1 over x to the 4. So you've got minus 12 times 1 over x to the 4, which is just minus 12 over x to the 4. So if you want to write it in this format, we're going to get minus 12 over x to the 4. Right, these longer questions, so we're going to find the gradient of the curves at the given points. So just like we did before, we're going to differentiate this. So we get dy by dx times by the power, 2 times 3. Take 1 off the power, gives me 1. Power here is 1, times by the power gives me 1 times minus 3. Take 1 off the power, see that this rule holds. You could just think of it as y equals mx plus c, just for that bit. Or you can follow the rule, it doesn't really matter. x to the naught is 1. So we get 6x to the 1 is x, minus 3x to the naught. Anything to the power of naught is 1, so it's just that. So our gradient function is 6x minus 3. Now at x equals minus 1, dy by dx will equal 6 times minus 1 minus 3. So it's minus 6x minus 6 minus 3, which is minus 9. Do this one. So we're going to differentiate dy by dx. For x, I'm not take 1 off the power, 3 plus this is going to be 4, and the 5 doesn't affect the gradient function at all. So at x equals minus 1, we get dy by dx is equal to 4 times minus 1 cubed plus 4. So that's minus 4 plus 4, which is 0. Find the coordinates of the points on these curves where the gradient is 0. Well, I'm just going to do one of these examples and then jump ahead, okay, because I want to keep this video reasonably short. So first of all, differentiate. So I differentiate and I get 2x minus 4. Now I want to find where the gradient is 0. So I want to solve 2x minus 4 equals 0. So 2x equals 4. So x equals 2. So the x value is 2, but I want to find the y value when this happens. Put 2 back in. So y is equal to 2 squared minus 4 times 2. So it's 4 minus 8 gives me minus 4. Right, I'm just going to page down to this trickier one and we'll finish the video there. So we've got y equals 25x. We're going to change this to a negative power plus x to the minus 1. So dy by dx is equal to 25, because 25x just goes to 25. Remember, it's x to the 1, so you times by 1, get 25. Take off the power gives me 0. X to the 0 is just 1. Times by the power, minus 1. Times by x, take 1 off the power, gives me minus 2. And if we simplify this, we just get minus 1 over x squared. So our answer is 25 minus 1 over x squared. And we want to find out when this equals 0. So times throughout by x squared, we get 0 times x squared is 0. 25 times x squared is 25x squared minus 1. 1 over x squared times x squared is just 1. So I get 1 equals 25 over x squared. 1 over 25 equals x squared. Square root both sides, I'm going to get plus or minus 1/5 is equal to x. Remember, when you've got x squared equals something, you always get plus or minus. So you get 1/5 is equal to x. So we've either got 0.2 or minus 0.2 as my x values. Put those in. So I'm going to get 0.2 plus 1/5 of 25 is 5, plus 1 divided by 0.2 is also 5, so that gives me 10. And put minus 1/5 in, so I'm going to get minus 5, and I get another minus 5, so that gives me minus 10. And that is my answer to that.